can cut it into the agenda notes and then put it in the chat when the meeting starts.
Sure, sure.
Hi, Brian.
Hey, how are you?
Good.
Hello.
Boy, this is
I'm
really out at the edge if you're doing it from your car, or is this?
Yeah,
a
I'm not
demo?
driving. I'm helping someone move today, and I really wanted to join this. So
That would look cool, though, if you could do a live demo of something.
right, exactly.
So I was just telling Dion. Dion is a co-chair of this group that you were going to appear today and introduce yourself. To be honest, I'm not sure what kind of turnout we're going to get because, you know, here in the US, it's a day after election day. And I think a lot of people are zoned out and not at work, and we'll see what happens. But
I hear you. I want to get engaged and get started, if any, at least, right? So.
And I saw somebody joined an hour earlier at 8, and we'll see if he comes back. I think the time zone change here threw some people off, and the right way to do this, in my opinion, is to go to the Kubernetes community calendar and cut the invitation out of there, because then it auto adjusts. But I think a lot of people just make a personal entry, and if it isn't synced to the time zones correctly, they get off. And we have this thing going on in this group where we have alternating meeting times so that we can accommodate Asia and Eastern Europe. So our alternating meetings are actually at a different time.
Got it. Yeah, I was noticing that. All right, makes sense.
Yeah, I don't know if we had it to do over that we would do it that way. We started out with one, then we announced that, and unfortunately you get these meeting times out there, even in YouTube videos that get recorded from years ago, and somebody starts watching them and sees in the video that this is the time, and it has become wrong, but there's no way to update it. And I've learned that the hard way that it's treacherous to shift any of these things once you get started.
Yeah, makes sense.
It's 2 minutes after. We'll give it another 2 minutes. I see Moritz has joined. He's a regular here. Okay, I pasted a link to the agenda notes document in the chat. If people would like, you can drop your name in the attendees list. We'll get started in 1 more minute. Chris, I see you joined just as I was sending something out on the chat, so let me know if you don't see it, but I sent out a link to the agenda notes doc. We're going to get started. Well, we'll get started right now, but if you would like, you can add your name there. So to get this meeting started, the standard advisory is that this meeting abides by the code of conduct of the Kubernetes project and the CNCF. That just means be nice to each other, but it also means that all meetings are public and recorded. So I'm about to start recording, and the recording will be uploaded to YouTube. If you don't like that, your options are to drop or to leave your video off and mute yourself, I guess, and maybe change your name to an alias if even that offends you. So with that said, I'll push record and we'll get started. Oh, I guess Dion, you already started recording. Okay.
I haven't, but I think it's auto recorded. So
okay, maybe it's set to auto record. I didn't know that. Okay, welcome to the November 4th meeting on the North America time cycle for the Kubernetes IoT Edge user group. Today, we've got one item on the agenda officially. I think we've got just a reminder that Dion will give also. But as always, members are welcome to add agenda items. So if anybody has any late adds, I think we might have room for it. So go ahead and just patch that in there and we'll get some time to talk about whatever you want. I think this is likely to be one of these relatively unstructured things that goes in a birds of a feather discussion open for anything. We do have a first-time visitor here today, Brian Rodriguez of Intel, and maybe the best thing to do since we're small is to go around doing introductions just to kick this off. And then after that, Brian wanted to have a discussion about what's going on with Kubernetes IoT and Edge at Intel and how those activities might interact with this group. So for introductions, Dion, do you want to kick it off?
Sure. So my name is Dejan. I work for Red Hat for a long time. Been doing a lot of messaging in the past, and then for the last couple of years, been more involved into the IoT stuff and particularly more on the IoT cloud stuff. And then at some point we started this IoT Edge working group here to further discuss how Kubernetes can be used for IoT and Edge solutions. So that's
okay. Thanks.
Where I am
I'll go next. I'll just do it in the order I see it on the screen. I'm Steve Wong. I'm a software engineer with VMware. I've been working on Kubernetes since about 2016, but most of that has not been related to IoT Edge. I started out working on aspects related to storage. My interest, though, in IoT Edge is that kind of a long time ago in my career, I was affiliated with a startup called Wonderware that did IoT before it was even called IoT. And I've held on to an interest in that. So started going to the meetings of this group, and they invited me to become one of the tech leads of the group. So that's how I got here. Brian, do you want to go next?
Sure. Brian Rodriguez with Intel. I'm in the IoTG group, a platform architect, and my background has been, building internet service providers, then cloud service providers, to managing lots of remote devices before Docker containers was a thing, to where we are today, trying to manage the edge and orchestrate the edge from industrial to retail. And if you could have multiple markets, if you had those at two extremes, to me, those are two extremes. But yeah, I include vehicles, robotics, and along that. But our objective is here. We'll discuss that. So glad to meet you all.
Okay, great. Hey, Chris, why don't you go next? I see in the agenda notes here from Canonical, so maybe you have something to do with microcates, but if not, tell us more.
Sure. First of all, is my audio working? I haven't used Zoom previously.
Yeah, it's great.
Fantastic. So I'm from Canonical. My background is actually from electrical engineering, similar to what you were saying. I worked at an IoT startup a long time ago called Synapse Wireless that did wireless and mesh. And so I've been interested in IoT and kind of edge hardware for a while. I'm at Canonical now. I've spent the last 4 or 5 years at Canonical running Kubernetes and OpenStack. So I've been from kind of an operations perspective, but I've recently joined the Kubernetes team, which is responsible for our Charm Kubernetes and microcates. And I'm really interested in how those kind of mesh with Edge and IoT. So I thought I'd start joining here and see where the discussion's going and where Kubernetes and Edge look like they're coming together, and how microcates and all might play into that story as well.
Okay, great. By the way, we had a presentation on microcates, I think late January, early February is my recollection. Kind of a nice how-to demo, but we could potentially use a refresh because I know a new version is out. So if you'd ever like to do that, we're up for it. And I think
Okay.
about 2 meetings ago, we had kind of a nice birds of a feather discussion on a lot of people going to intro to various radio protocols for a mesh, not in necessarily the Istio context, but kind of in the what you might see out at IoT when you didn't even have a wired scenario yet. We're trying to run data communication meshes. So these meeting recordings are up on YouTube, and you can probably find that. And if you look
Cool.
through
Yeah.
the agenda notes, just scroll down a couple of meetings, and I think you'll find enough to tell you which meeting that was. But
Thank
I
you.
know
Yeah,
I
I'll look
learned a
into that.
lot in that one. Maritz, how about you introduce yourself next?
Yeah, sure. Yeah, my name is Moritz. I'm currently working as a PhD student at Aachen University in Germany for the chair for laser technology. And I'm currently basically writing my thesis on a platform or on a let's say, yeah, platform is pretty good for that, on how to control laser production machines with Kubernetes. So on how to basically build a manufacturing system that completely runs Kubernetes top to bottom into the edge, so that you can deploy not only like the software that is running on the machine itself, but you can control it with, for example, operators or stuff like that.
And I think you told us in the past you're trying to use image capture and things for that as a control loop for
Yeah,
laser
exactly.
cutting.
So one of the use cases we have is that we have insane speeds. So our process runs at like 3 to 4 meters per second. So we need image data that is like, I don't know, 1,000 to 15,000 pictures per second. And we want to basically run algorithms on that on the fly to control our process. And the idea was to use Kubernetes to like change the algorithm that kind of yeah, analyzes these picture streams. And that's what I've been working for or on for basically 1.5 years now, and it's still like going hard.
Okay, thanks. Yin, why don't you introduce yourself?
Yeah, I currently working in the Future Way about the on the Kubernetes project. So almost full time, a majority time on the Kubernetes. So I'm very interested in, to collaborate with Edge IoT with the Kubernetes community together. Yep. Also, I may drop off early today, so that's meeting conflicts. Thank you.
Okay, thanks. At this point, I know Brian wanted to introduce who he is a little more, maybe in his group. So, and maybe ask some questions of the group. So I'll turn it over to you, Brian. If you
Okay,
have
great.
anything you need to share, well, might be tough from your car if you're using your phone.
Not today. I'm not ready to. I sort of
Okay.
wanted to get introductions going, and then we'll see if this is the right venue to do it. Okay.
Okay, sounds good.
So one of the things that, you know, and obviously Intel's a hardware company, but we want to engage, and we understand that orchestration and manageability, we have a lot of really good ingredients, but we really need to make some software decision making with a community. And one of the things that I don't know how much you guys have seen of what we're trying to do is automate more of the expense of what it means to clusterize at the edge, including even physical discovery devices, because our customers are starting to come back to us and starting to realize, hey, we can't really apply the same technologies that we've really been doing from the data center point and at the edge. You know, there's a new attack vector. These don't have some places don't have a nice air conditioned environment. We have people picking things up, putting things down, plugging devices in, removing devices, and all of these are changing the orchestration and manageability dynamics a bit from the cloud sort of data center model. And as you further you go out on that edge, that becomes more and more prevalent. So what we've been trying to do is our IoTG is coming together, trying to create a more of a one voice story between all of our verticals and try to create a common base sort of reference, et cetera. And one of the things we're noticing is gaps in just scalability and deployment and the cost of just to run Kubernetes at the edge and just assembling. And so we've been spending a lot of time in autonomy and just even zero touch, you know, secure device onboarding you guys have seen. If you have not, that's on LF Edge. And beyond that, in automating and self-healing of Kubernetes and cluster orchestrators. We've had a number of customers come in using Nomad, Mesos, Docker Swarm still. And we've had a lot of pushback for different areas in the smaller IoT from a Kubernetes point of just because of the sheer size of what it takes to run. It's just not cost effective for those retail folks. But when you come from an industrial side, heck yeah, there are. So we're trying to create this one story and try to go to our customers. No, you should really go to Kubernetes because there's a lot out there in the ecosystem. But we want to also evolve and help give feedback to the Kubernetes and working group to say, here's what we're seeing. How can we make more efficient hybrid models as you approach the far edge? And then another new thing that's coming up a lot for us is, you know, a lot of folks think of the singular vertical management. Let me try to explain. You know, you manage a single device at the edge and that connects back to the cloud. But what we're starting to see is well, how can I have a group of 3 devices run on their own with autonomy, and there's a connection between them that goes up and down, right? Not a single device, and let them still orchestrate beyond amongst themselves. And let's say in a robot, you know, something that's delivering something that needs to still function while disconnected from the cloud. However, you'd like it to check in because the cost just to go and check in is there's an expense. And if, you know, there's 10,000 of these units, these are the type of use cases we're running into, but people want Kubernetes. And so what we would like to do is see if this is the right place to engage with you all, start working together, start exposing some of our technologies and our capabilities from a hardware aspect. We have a lot of push to try to increase our telemetry in a more common bound way up to Kubernetes to make better decisions, help with trending analysis. There's a lot of software that does it, but, you know, I would say from an Intel's point of view, there's not an organized way for us to expose that to Kubernetes in an efficient way. And we want to be engaged and hear from you all. Well, how can we help? And also what our engineers can do to help enable you and you enable us. So it's, you know, we'd like to see a collaborative approach. And, you know, and as an Intel, as a hardware company, we'd like to be more involved in understanding what it means from a community and working group. I've been part of other software working groups in the past, but from an Intel's point of view, this would be my first engagement. So does that make sense?
Yeah, it does.
Is it resonating?
It is. And I
Perfectly.
think that we've had historically a big part of this community showing up to meetings, maybe more so at the big tent things we've had at physical conferences that recently have been kind of moved to Zooms, so they can't be as interactive. But we've had events where we've had in excess of 200 people at presentations at KubeCons, and then had hallway track things going on afterward with major groups of different use cases for Kubernetes Edge IoT. They fell into camps of telcos were a major one. Industrial IoT is another. Data capture, and I'm throwing this in, but it's Maritz's category of, it's pretty broad what that means. Anything from security cameras to Maritz trying to do a control loop based on video. So, and I've even heard of things like fast food restaurants using cameras to monitor things like arrivals of pickup orders, and
there's a long
queues.
list of that.
So
Yeah.
there's a lot of that falls under the video category, and I'm not sure how uniform they are. And then smart cities, although I don't think we've had large numbers of those people show up to meetings, but there were small numbers of them. And then, of course, vendors in the space. But a lot of times vendors can stand in as a proxy for their customers just because, you know, in many cases, people will use a vendor just because they don't have the time to go send their staff out to open source communities to be active and kind of, in effect, delegate that by going with a commercial distribution. Summarizing it all, I think you're on point with the problems from big data center versus out at edge. The one that comes up over and over is lack of physical security, creating some real challenges. Also, lack of trained staff to do maintenance, so that the stuff has to be, I wouldn't say necessarily fully self-provisioning, but pretty close to it, where you can send an unimprinted thing out to a field location and have it somehow auto install, and maybe even more importantly, keep updated, because if you don't keep doing that, it's only a matter of time before you got big problems.
That's actually our group. What we've been spending the last 3 to 4 years doing a lot of work trying to simplify that zero touch provisioning with your low cost technician doing the actual onboarding. And again, there's a big cost at scale there. So
yeah, and
we really would go ahead. Sorry.
The other recurring thing with Kubernetes is that the fact is that there's tons of devices out there that probably the numbers dwarf. Yeah, there's tons of devices that don't have the compute resource to run Kubernetes in the sense of being a Kubernetes worker node. And in fact, I'd say the numbers dwarf the capable devices by maybe 3 orders of magnitude, maybe even 4.
That's a huge, that's been a big problem.
Yeah,
that's exactly where we're at.
Yet Kubernetes is it was designed from scratch to be an extendable control plane. So there's a lot of people who are doing investments in writing CRDs, custom extensions to the Kubernetes control plane, so that even if it isn't a containerized workload or even containerizable, there's a chance that you can use the Kubernetes control plane to do configuration and maybe even things like firmware updates of devices that don't even run Linux. You know, there's no reason you couldn't use a declarative API to say that, hey, in this temperature controller, I wanted to have firmware revision 15.7, please make it happen, and use gateway devices or things to control it. And the other reason that it's compelling at edge is the life cycles tend to be much shorter than what you have in data centers, whereas data centers run maybe 3 to 7 year life cycles, actually probably rarely over 5. Yet out at edge, you're talking decades pretty easily because of the logistical cost of replacing that stuff and budgets where, hey, if it works, if it ain't broke, don't fix it.
Exactly.
And that isn't going away. Yet the pain points are there, so that if you could come up with tech that would allow Kubernetes to fit into that story, and I think managing configuration and updates is big, managing networking, even when the networks aren't IP based, you know, that maybe are, you know, radio mesh protocols and things. There's no reason somebody couldn't do something like an Istio, but for non-IP networks, if the investment was there. And I know Intel even has, you know, you certainly have your Wi-Fi and Bluetooth chips, so maybe there's an Intel story there.
There already are. I mean, I'm hoping this is the right place where we engage and start collaboratively connecting these dots. So
yeah, I don't want to take this over. So that was just an attempt to recap. If you had gone over the videos of our past meetings, I think you would pick up on that.
Yeah, but, not all of them. But
Maritz is the actual user here. And then Tina joined late. Just as an intro, Tina, we're doing kind of a birds of a feather. And Brian is here from Intel, just trying to learn the lay of the land with Kubernetes and IoT. But Tina, I think, has a broad exposure because she's involved with the Grano project. So Maritz and Tina, maybe you want to jump in and talk too. I'll mute my mic and shut up.
should I go first or?
Yeah, go for it.
Yeah. So yeah, the problem we run into a lot is just like basically the diversity on the edge, that because you have so many different protocols, so many different manufacturers, so many different so many different people doing stuff non-standardized ways that it gets really, really complicated really, really fast. The funny thing about Kubernetes is that you can basically pull everything together. It might take a lot of time to like implement something like, so we have done Modbus, for example, with Kubernetes. So you deploy basically in Kubernetes deployment or a daemon set or something like that. And this one can talk Modbus. And then you can control, for example, some kind of robotic system or a movement system or something like that. And that works wonderful. But of course, it's like really messy, or it gets really fast, really messy, because you implement all of the special use cases in different services or in different microservices. And that just doesn't scale very well. And that's what we have been running into in the last few months, I would say, that there is like not a standardized idea on actually how to use different protocols. So that might be interesting in the future to just think about that, like how can we leverage maybe Kubernetes to jump from one, let's say, communication system into another. Yeah, my 2 cents on the topic from a user perspective. Yeah.
Wouldn't the objective though to be to use Kubernetes to deliver the workload or the bits to enable that other communication?
Yes, exactly. That's what we are actually doing right now. But the problem with that is that every vendor implements his own version of that. If you know what I mean.
I do know what you mean. Yeah, I get you.
So like Modbus, for example, you can communicate with your manufacturing machine with that, but the position of bits varies from manufacturer to manufacturer. And sometimes we have like, I don't know, 16 bytes, sometimes you have 32, sometimes like Modbus, for example, is just crazy. But and the funny part is that I really would like to see something like a conversion thing, like going from, for example, REST or gRPC to something like Modbus or something like that. But I'm not quite sure on how to actually deal with that, or if it's just the Kubernetes we're actually just using right now to basically deploy some kind of gateway that translate service calls into Modbus calls, for example, and does a little bit of error checking and a little bit of smartness along the way, but not that much fancy. And of course, you can do that for every manufacturing system you own. That's not a problem. That's just like, you just need to code a lot, let's say it like that, and you have a million services afterwards. But it works. So we have done that for, I don't know, 7 to 8 different manufacturers right now, and that works perfectly. But I think that will not scale up very good.
Yeah, I was just about to inject that it's been my observation seeing things where I can't recount how many times going over decades where people put in place what I call a dumb translator that just does a one-for-one remapping some proprietary protocol up to TCP. And some recent hire goes and says, look, I got one of these running, but there's security issues on it and scale issues where really when you think about these IoT devices have simple protocols that maybe didn't anticipate security, have very low compute capacity. And if you just do a translator that maps that out on the internet, you're exposing it to these denial of service attacks where just reading, asking for the temperature over and over, you would think, well, it's read only, what's the harm in exposing it? But some of the stuff collapses if you ask for the temperature 1,000 times a second and it falls apart, and then your actual use for it goes out of service and you got a big problem. I think a lot of these seem simple until you try to scale it or really analyze the full threat map of what could happen with that one-to-one exposure. So it ends up being something where you need a little more intelligence, and I call it governance over it, to where in general, it's almost always going to be a bad day to get that stuff exposed up to the higher cloud tiers, one for one, without some intermediary business logic that really is the only one allowed to talk to it. The other
like
thing
rate
is,
limiting.
yeah, and maybe even authentication of who you are. So fine, cache it and let people read it out of the cache, but there isn't a direct pipeline if you really want to expose that to broad use. The other thing is, Brian, you said use Kubernetes, to get the data to these, but really I think even in a data center, Kubernetes really is just control plane. And if you look at how container images get there, it's really sidebar where the container runtimes pull from a registry. And there is activity there of registries for container images, plus some of these registries are extendable to be kind of generic blob stores to some extent. But when it comes to device firmware updates, maybe there's even some customized ones too. And there are some open source projects that I think some of these came out of the automotive industry where they wanted to do firmware patches into the many computer devices inside an automobile. But there's a lot there that I think is potentially reusable. I think the telco industry also has things, their own projects for distributing effectively binaries for various uses.
We've engaged in a lot of those different telco plus vehicles. We've been working very much with even using containers as a delivery mechanism to help do that. But we spend, like I said, from a bottom-up approach, we've been spending a lot of time around security, full attestation for hardware in case it's lifted. This thing will self-destruct if it's not connected to the network for a matter of 30 seconds, right? A lot of those use cases we've been spending time, and I think it'd be nice to at least expose and share with you all and see what we can. And what about time-sensitive networking? Does that ever come up?
It does, like time series data, certainly. We haven't had like a detailed presentation on it, but the stuff is clearly out there. It's actually been out there pre-Kubernetes too, when you get down to it. And in a way, Kubernetes does use that for some of the metrics and data logging. But then I think we had a discussion a few meetings ago about the really hardcore stuff where you need potentially single-digit microsecond precisions, things like doing root cause analysis for failures of a power grid at a large scale. There have been people talking about the pain points. I'm not sure we've ever had a presentation on how you go about solving it, but
we've been mixing video inferencing with time series, time-sensitive networking. So, with timing for life-saving events, right? People's, hands could get chopped off in an industrial situation, using video to kind of watch these things. And, okay, so it's there, but it'd be worth going into.
Yeah, I think there'd be a lot of interest in a presentation on it if you could put it together.
Yeah.
The other thing I know Intel does is the TPM modules and the tie-ins for what does it really mean to be trusted? Because in my experience, the average software developer knows they need it, but how it's you difficult. Actually hook that up and, an overview of that pattern of how you would actually take advantage of a TPM module to build what it is you need to build and
Yeah.
get it to work end to end. That would be,
Yeah.
I would like to watch that myself.
Sure. And you know, it's not just the TPM, it's the secure boot guard all the way up from this machine testing all the way to your bootstrapping all the way up using the TPM as your facilitator. But here's another thing. The biggest challenge has always been getting the OEMs and you know, the SIs. Do you want to manage your keys?
Mhm.
Is that's where it starts becoming the headache, and a lot of system integrators are starting to go, we don't want to depend on the ODMs or the OEMs to do it. We'd like to be in charge of it, and that's fine.
I'd like to, I think we,
comment
oh,
about
go ahead,
the
Tina.
time-sensitive network. So Intel and FutureWave, they have already created a blueprint named time-sensitive edge something in Equino since release 2. If you're interested, you can have a look.
Cool.
One question about time critical, like how time critical is time critical? Are we talking like milliseconds or seconds, or?
It's a little of both. It depends on the situation, and when I say this is, it's mainly it starts being how synchronized the number of nodes we have together with the video coming in. If we have multiple inferences separated by multiple nodes, how can we make sure there's synchronization between them, interacting with devices on the floor, if you will, in the industrial situation?
Because I've pulling my head around this problem. Like, how can I introduce something like an emergency button into a system like that? So for example, you have like a robot running around, and then the robot has like a service running, so you can control the robot. But now I introduce this button, which basically has to stop all of these hardware layers, maybe on a hardware level, of course, but that wouldn't be ideal, because that would mean like when I introduce a new button into the system, I would need to rewire everything and hook the whole thing into the safety wiring again. And I'm not quite sure on how to handle that elegantly, like wiring something like a security lifeline into something like Kubernetes in real time, like I don't know, 1 millisecond or something like that, so that you can shut everything down in like a millisecond, but Ethernet TCP/IP, you know, it's a good.
Yeah, that is a challenge, especially the way if you don't have guaranteed reliable networking, queuing layers inside TCP could really burn up that millisecond on you. Historically, I know in industrial control, which I used to do, a lot of people look at digitizing that and then end up going with even analog solutions or really local loops. You know, things like safety for power saws often are done now with just a circuit that detects a capacitance change if a finger touches the blade, and then detonate an explosive charge to do a mechanical break. And it's pretty tough with, I don't know, I wouldn't want to trust my life to Kubernetes today, even though I'm pretty comfortable with Kubernetes. I'm not sure that, you know, if a saw is about to cut my head off, though, I'm that confident in it.
Well, that's why, you know, we always say, like you said, sidebar or something. Kubernetes is that thing to facilitate in the orchestration, but it's not the real time. It's not the engine that's actually interacting. It just made sure that thing got there to manage that real time sensitive piece. So that's how we've been treating it.
Yeah.
One thing I wanted to comment on your last comment, Brian, is I see Kilton has joined us. I don't know if he's in a position where he can talk, but if he is, I consider him sort of an authority on the subject of security. He contributed a lot to the security white paper. And Kilton, if you want to jump in there, and if you can talk, we'll give you a chance to unmute. Okay, maybe he's in a situation where he's listen only.
Yeah, I watched some previous YouTubes of where he's from, so. Well, I'll just say that this sounds like the right place to continue to interact.
go.
And oh, there you go, Kelton.
There we
Okay.
go.
Take
Sorry
it over.
about that. There was a couple different mute layers, my car mute layer, and then I was about to say something before, but Steve, you were saying so many great things. I didn't want to interrupt. When you were talking about how these lower layer protocols get mapped up into the upper part of the stack, you have all these security problems, and they were never designed for security. And I was going to say they were, but in a way that we don't normally talk about. They had implicit security in that you had to be on the wire, right, to use some of these protocols, especially the ones that were over serial, right, and not even Ethernet. If you weren't physically located right next to the machine, then there was no way to communicate with it. So the inherent security there made it possible to just stick to the byte transmissions and not worry about any authentication or anything. And of course, when you bring that above to the layers above, you then expose that implicit security is out the window, and now you have to add something, right?
Yeah,
and
that's an interesting observation. It's just like you commonly use localhost on a CPU, but if you were to put something in place that lets a remote outsider pose as localhost, you got a big problem.
Exactly right. And so there's this trust layer there that honestly, like, I don't know that we would have made it if we had to have everything internetworked all back in the day. I don't know that we would have been able to make performant closed loop systems, right, because of the overhead. Now I think we can handle the overhead. We just don't know how to structure it. But I wouldn't want my real-time closed loop type decisions being made above anyway. I would just want to be able to change the directives, right, using the orchestration system, and then let them get carried out. So yeah, but it's like, I was just thinking that, it's like, yeah, it's actually, it's not that these things never anticipated interconnection. It's rather that they wouldn't even make sense, right? And so anyway, thought I'd jump in with that.
Yeah, I can't agree more. I can't agree more. It makes logical sense.
And so I would add.
So it's basically the implicit security that is biting in our butt right now, right?
Yeah, this is biting us in the butt. Yes, it is. Yes, it is. And the earlier part, which I came on at about 20 minutes after the hour, the earlier part that I heard was also about just the nightmare of the various implementations of I guess you could call them different implementations of like Modbus, et cetera. It's more like Modbus technique works, but the registers change, right? And the number of bytes coming from the registers changes, and all this nightmare. And it's like, there are plenty of like, Modbus, CAN bus to rest systems out there that are proprietary, and you pay a license fee. And I hear that they work really nicely, but the issue also becomes like, what do you need where, and how do you make sure that the low latency real-time traffic stays where it's supposed to stay? And then you might need some insights from it, and how do you bubble that up? And because I definitely don't need my Modbus data flow to go directly up to any cloud backend. I might need it to go one hop higher on the edge environment, and maybe I make some changes in decision right there, and they're on a very low latency, but not what I would call kind of closed loop real time. That's possible. I would definitely think that trying to find a universal protocol adaptation layer is probably going to be more like finding a universal approach to identifying what you need and pushing it out. That way you can continue to customize it. That's what I've always figured is going to emerge. Is like, here's this particular flavor of Modbus for this scenario, and how do we detect that we need it and automatically orchestrate it down for these 5 edge nodes? It's really about putting the application workload close to where it can do that talking, but definitely better if you can have something like, I don't know, maybe 100 or so, commonly used adapters from low-level protocols upward that have security and stuff built in them. We could probably cover a a lot of bases with about 100 or so, but to get 100% coverage is going to be, 1,000, 1,500, whatever there are, number of protocols in the OT space, right? So anyway, those are my thoughts, because I didn't interject them before, and they're very similar to what's been said.
Yeah, I think really my observation is that those protocol converters are a building block, not the end game. And the key thing you want is not one-to-one mapping exposed up to the cloud, but really grab the data and catalog it. And cataloging is of key importance. So move it up to a layer where you can publish it and make it easily discoverable what it is, so that you can do data mining. And then it isn't just static data, even if it's time series, but there's also use cases based on events or transitions that can drive event-driven architecture. This will be a segue. I'll let Dion talk about our upcoming talk at KubeCon North America. But one of the ways I think to generify this legacy data is to turn it into events that can be plugged into the existing open source projects that deal with event-driven architecture. And so the keys there are not one-to-one expose everything, but cherry pick what's important data-wise, publish it in caches so that it can be used at upper layers that maybe aren't so latency sensitive. And at the same time, potentially mine your event transitions or state transitions and make those publishable at a higher level of business logic. Anybody else got thoughts?
That makes a lot of sense.
Yeah. What I just thought about when you meant like monitoring and observability of system, what I found really interesting, or what we started playing around with in the last few months, basically, was combining our services with ontologies. So that, for example, you can do like conversion, or like metric, not metrics, like let's say you have some kind of robotic system and you send it something like move left 2 meters or something like that. So you send it a 2. And of course, you need to make sure that actually what you're sending your system is a 2, and that the client that is actually connecting onto that IoT gateway actually knows that it is working with a system that expects a meters and not a centimeter value. So what we have been working on is basically on how to inject ontologies into your Kubernetes service, so that you can check before you run your job, or before you want to control your system. Like I wrote my job that I expect movement control to be in meters and not in centimeters. So you define that beforehand, and then we have like a little script that checks if every call would break anything. So that I sent like a 2000 instead of a 2, and then my robot would crash somewhere or something like that. That is really interesting to run on Kubernetes, because you have like this definition, or this, you can basically embed that in your service, like this definition on what is actually going on the edge, but in like a structured way. And that has been a lot of fun to work with, because it's like, so far it's basically open territory. You have stuff like Open API or gRPC, but they are not really worried about this checking on stuff, like they expect you that you know what you are sending, but they don't basically check if the value is actually right that you are sending. And that is, I think, pretty critical, especially when you go into the edge field, where stuff does change, and where some guy develops something with I don't know, meters per second in mind, but somebody else wants to have centimeters per second. And now they have to like worry about that, and they don't want to crash stuff.
That makes a lot of sense to be concerned about, because we are entering for the first time into, I would call it kind of like a multi-party edge and real-time and industrial system world. Previously, all the software was done in the same stack, usually by a small number of vendors, and implemented by the core team that probably were doing all the checks and balances and test runs. Here, you might throw an edge application into the mix for management of a machine, and even if it's made by the very vendor that made the machine, it might have been built by an outsourced team that they hired, right? That doesn't have as much experience, or it's a new model. There's a lot of possibilities to throw things off by factors. And I would definitely not want the movement to be swinging 10 times, faster, 100 times faster or farther than was intended. That'd be terrible.
So you would say that's actually a good way to go, and we should investigate this even further, right?
Yeah.
Perfect, will do.
Steve, you're muted.
Oh, one more thing on the agenda. Dion and I are doing a event-driven architecture presentation for KubeCon North America in a couple of weeks. Do you want to tell more about that?
Yeah. So basically, we are covering event-driven architectures for IoT and Edge, and it's been something we've been doing for a long time. But specifically, we've been focusing more on Knative eventing in the session, and something I've been playing around with in the last couple of weeks or months or so, and how we can use Knative eventing, and it touches on top of this, and how maybe we can use a cloud events and try to standardize on the basically payload, so to say, metadata format for the telemetry coming from different sources. So yeah, I'm sure. So we are just scratching the surface. I'm sure we'll talk a lot more about that at these meetings after the KubeCon as well. So
yeah, part of that is we actually tried to do a live demo. I'm not sure afterward, we have to record these, and some of this was some command line stuff that is potentially harder to see, but I actually put on the air some temperature sensors in my house, and they went out over MQTT to a Mosquito gateway, and then Dion went and rendered them graphically, feeding them into, well, you what was it, the camel driver going to?
Yeah, we have a camel K source that was reading from the MQTT external MQTT broker, getting that into the Knative stream, and then pushing things to InfluxDB and Grafana. Just a little bit demo of the flow of the things that could go, but yeah, it's pretty good for a nice little demo.
And there's a few other things. I don't know any details about them, but I went over the KubeCon agenda, and there's some interesting Edge sessions there. Strangely enough, there's one, this is the story of my life, name collisions with the name Steve Wong. So there is actually a presentation by Stephen Wong on service mesh at Edge, but it isn't me, it's somebody else who shares my name. But I was going to catch that anyway. Then there's one on getting your application bits to the edge using the Harbor image registry. And I think there were a couple more. There's definitely a KubeEdge session in addition to ours. So I would recommend that. I don't know if they're still out there, but there were discount codes floating around for KubeCon, so that I think you could get it, for $25 or so. And I think they have scholarships if you're with a nonprofit or university. Once again, I'm not sure if they're still out there, but I think I've seen them. So it's inexpensive. If you can't make it, I think ultimately about a month later, they end up uploading them to YouTube anyway. But yeah, I'd recommend catching that conference if you're at all interested. The other thing to check is I believe there are some pre-events. So I didn't look this time to see if it's there, but the service mesh for telcos has had pre-events at KubeCons in the past, so they might be having one. But don't just look at the main event schedule. I'd recommend that you look for the co-located events as well. So we've got 5 minutes left. If anybody has any last minute things they want to suggest for the agenda, and if not, we'll call this to a close a couple minutes early.
I just wanted to thank everyone, and it looks like we'll have I'll be joining more future, and I'll add some topics to the next agenda or as things go on. Okay.
Okay, and if anybody wants to reach you, Brian, I assume, can they get you in the Kubernetes Slack? Have you got an appearance in there?
Yep,
with
and then
okay.
on the attendees, I'll make sure I put my name on there.